All right, so let's take this example. Let's consider the curve f of x equals square root of x from 0 to 6. All right, and we're also going to throw in the curve just y equals 1. So it's just this horizontal line. All right, y equals 1. And what we want to do is we want to take the region that is bounded by those limits, and so this region right here, and we want to rotate it around the x-axis. Okay, rotate it around the x-axis. So if we do that, we're going to get something that looks a little like this. Right? And remember, it's solid. Oops, I gotta be a little more careful here. Something like this, because we have this kind of hole in the middle. Right? All right, so it's like this. I don't know. It's like a hollow tip bullet, I guess. This little area right in here is hollow all the way through. This is solid, and so we would like to find the volume. So the way you do this is you again go over a distance x, and you take a really thin slice. This is much thicker than it would really be, and the thickness of that slice is that. Now the thing about this particular slice is when you take it, it's going to have a hole in the middle. All right. Right? And so we call this a washer. And so what we need to do is find the volume of that washer. Well, it turns out that the volume of the washer is not too hard to find if you know two things. You need to know what we call big R, the big radius of the washer, and then little r. Let's put it in this color. Little r. All right? So if we put them on our graph over here, big R is this distance, and little r is this distance right beside it. Okay? So what you do is you find the volume of the big outer disk, and then you subtract the volume of the hole, the inner disk. And so the volume will look like this. In general, it's just going to be, this is the volume of the big disk minus the volume of the little disk with little r. If we factor a little bit, we can pull the pi out, and we just get r squared minus big R squared minus little r squared dx. So there's going to be the volume. This is a method called the washer method, and we'll always end up with that as our volume of the washer. So all we have to do is find the big volume. Now the big volume is given to us by this top curve, by square root of x. So in our case, when we go over distance x and make our slice, our big volume is square root of x. Okay, and then we square. Now the little volume is just this distance from our axis of rotation up to there. It's just 1, and it's going to be 1 all through there, right? So we just have 1 squared dx. So if we clean that up a little bit, pi x minus 1 dx. Now that's the volume of that washer. And so the volume of the whole thing, I obtain that by integrating the volumes, the little dv's from 0 to 6, and we get pi can come out there, x minus 1 dx. Hard to imagine that shape, a solid that complex, has such a fairly easy integral to evaluate, right? So if we just crank this through, we end up with pi times 36 over 2 is 18 minus 6 minus pi times 0. So we end up with just a good old 12 pi cubic inches, or whatever our units are. And so that's the washer method, all right? You just have to find the big volume and the little volume and then run it through that. So using those two methods, you can find a lot of different kinds of volumes of different solids.